Continuing our review, given the equation, which is going to be in slope-intercept form, it looks, state the y-intercept. Remember, slope-intercept form looks like this. Y is all by itself. The value getting multiplied with the x is your rate or slope. This value is your y-intercept. So for number 42, the y-intercept is positive 4. For number 44, the y-intercept is positive 6. By the way, number 43 is kind of tricky. What number is in this position? What number is being added to the x? 0. The y-intercept is 0. Which isn't a big deal. As you graph it, it just means that as it goes through the y-axis, it crosses at 0. It doesn't cross through the positive. It's a positive y values. It doesn't cross through the negative y values. On the y-axis, it crosses at 0. Number 46, what number is getting added to the x? Negative 5. And the negative is a big deal. Negative 5 is the y-intercept. It's not the same as positive 5. That would not be correct. Given the graph, state the rate of change, which is the slope, from x equals negative 3 to x equals 2. In the solution set, the rate of change or slope is the value attached to or multiplied with the x value. So you're going to have to look at, again, this is slope-intercept form. So we just want to find the slope or rate of change. When you're looking at your answers or the answer key, look at what the number is multiplied by x. Look at what number is being multiplied with the x. I couldn't change the answer key, so whatever number's there is the actual slope. By the way, folks, these are linear equations. These are straight lines. So the region, I'm going to have to jump over to number 43 here. The region where x goes from negative 3 to 2 is this part of the line. But if I had more of the graph here to look at, I could use any parts of these lines. That's a different line, so it's probably a different slope. But the slope is the same all throughout the line. No matter how big of a chunk you take, when you simplify that fraction, that rate or steepness is always the same. It's the same steepness on this blue part as it is the green part, as it is this blue part. So all the rates and slopes are the same. This is just some lingo that Florida likes to use, so we're going to use that here too. You need to find 2 points on this line, on this straight line, any 2 points that you know the coordinates of. So like right there, it clearly goes through an identifiable point right there, and same with right there. They need to be going or at a specific integer location. I like to find slope if I'm given a graph on the graph. I'm going down 4 and I'm going right 2. So the slope is 4 over 2. Although I'm going down, so it's negative. So the slope is negative 4 over 2, which is equivalent to negative 2 over 1 or negative 2. You can find this a different way by getting the coordinates. The coordinate of this location is negative 2, 2. And the coordinate of this location is 0, negative 2. And then I'm going to take this, I'm going to put it in red so it's easier to follow. You can use the slope formula. And so the y value is 2. You should take the y minus the y. So 2 minus negative 2. And on the bottom, subtract the x's in the same order. So on the bottom of the fraction bar, you have to, again, start with this x, which is negative 2, and subtract that x down there. So negative 2 minus 0. And when you do this, you get, when you subtract a negative, it's the same as adding a positive. So you get 4 over negative 2. This fraction is equivalent to negative 2. So it doesn't matter. You can use the graphing version or actually write down 2 coordinates and use the slope formula. Whichever way you want to do it. I'm going to do number 51 with a picture. So this one's kind of tricky to find clear locations where it goes through integer values. I'm going to say right there and right there. Begin because it's a straight line. I don't have to really worry about that the domain of -3 for x to +2 for x. So I see that going from the green dot to the green dot, I drop down 5. So I'm going down 5. Now that's a negative when we're going down and to the right. Over time, if this is our money over time, it is going down, which is a negative thing, so it's a negative slope. It's not the story that makes it negative. When you go down and to the right, that's a negative slope. If you go up and to the right, it's a positive slope. All right, so this is my rise. Actually going down -5 as I go to the right 3. So the slope is -5/3. On number 53, I'll calculate the slope. The location of that green dot's -2, 1. The location of this blue dot right here is 2, -1. So let's use our slope formula. y2 minus y1 over x2 minus x1. So take the second y minus the first y. So -1 minus 1. On the bottom, divide that by the second x minus the first x. 2 minus -2. Looks like, I don't know, like, it almost looks like I have 2 negatives here. That's not cool. I'm talking about the coordinate of this location. The location's -2, 1. All right. But then, again, I do take +2, and I always subtract the coordinates, and that's a -2. So here I do have a double negative, and that will happen about half the time. You undo that by adding the opposite. 2 minus -2 is actually +4. On top we have -2. This simplifies to -1/2. Notice, folks, this is a negative fraction, and the line's going in a negative sloped direction. That should match. If you have a negatively sloped line, your slope value, or your fractional value for the slope should also be negative.